Black holes are one of the universe's most fascinating mysteries. Imagine a place where gravity is so strong that nothing, not even light, can escape. These cosmic objects are incredibly dense. They are formed when massive stars collapse at the end of their lives. Black holes are invisible to us. We can only detect them by their effects on nearby stars and gas. Scientists use telescopes to study black holes. They have discovered that black holes come in different sizes. Some are small, only a few times the mass of our sun. Others are supermassive, millions or even billions of times the mass of our sun. These giants lurk at the centers of galaxies. One of the most exciting discoveries in recent years was the first ever image of a black hole. This incredible feat was achieved in 2019 by the Event Horizon telescope. It gave us a glimpse into the heart of a distant galaxy. It showed us the shadow of a supermassive black hole against the bright background of its accretion disk. The study of black holes is crucial to our understanding of the universe. These enigmatic objects challenge our understanding of gravity. They push the boundaries of physics. By unraveling their secrets, we gain insights into the fundamental laws that govern the cosmos. Black holes are born from the death throes of massive stars. Stars are giant balls of hot gas held together by their own gravity. They produce energy through nuclear fusion in their cores. This fusion process creates outward pressure that balances the inward pull of gravity. This balance keeps the star stable. However, this equilibrium cannot last forever. As a star ages, it eventually runs out of fuel for nuclear fusion. Without the outward pressure, gravity takes over. The star's core collapses in on itself. This collapse triggers a supernova explosion. The outer layers of the star are blasted into space. If the star's core is massive enough, the collapse continues unabated. Gravity crushes the core into an infinitely small point called a singularity. This singularity is at the heart of a black hole. It's where the laws of physics, as we know them, break down. The region around the singularity is called the event horizon. This is the point of no return. Once something crosses the event horizon, it can never escape the black hole's gravitational pull. Not even light can escape, hence the name black hole. The formation of black holes is a testament to the immense power of gravity. These objects are a reminder that even the most massive stars are not immune to the ultimate fate of the cosmos. Imagine a scenario where a rogue black hole, wandering through the vastness of space, sets its sights on our solar system. This celestial interloper, a cosmic predator, approaches Earth with an insatiable hunger. As the black hole draws nearer, its gravitational influence begins to warp the fabric of space-time around it. This distortion affects the orbits of planets, including our own. Initially, these changes might be subtle, but they become increasingly pronounced as the black hole approaches. The once familiar dance of the planets is thrown into disarray. Orbits become elongated and erratic. Planets are pulled from their accustomed paths, their celestial ballet transformed into a chaotic waltz. Earth, once a haven of life nestled comfortably in the habitable zone, finds itself on a collision course with this cosmic abyss. The black hole's inexorable pull threatens to unravel the delicate balance that sustains life on our planet. As the black hole comes closer, its gravitational grip on Earth tightens. The planet experiences tidal forces of unimaginable strength. These forces, caused by the difference in gravitational pull on the near and far sides of Earth, begin to stretch and squeeze our planet. The once familiar blue sphere distorts, taking on an elongated shape. Oceans bulge outward, drawn toward the black hole's irresistible pull. Mountain ranges crumble and fold under the immense pressure. Earth's crust groans and cracks, unable to withstand the cosmic forces at play. This gravitational tug-of-war is not a gentle process. The Earth is subjected to a violent and chaotic dance with the black hole. The planet trembles and shudders as its very structure is torn apart. The once familiar continents home to diverse life forms are ripped apart like pieces of a jigsaw puzzle tossed into a whirlwind. The planet's surface becomes a maelstrom of molten rock, spewing forth from volcanic eruptions of unprecedented scale. Section 5, Spaghettification stretching towards oblivion. One of the most terrifying aspects of a black hole encounter is the phenomenon known as spaghettification. This gruesome fate awaits any object that ventures too close to the event horizon. Imagine a hypothetical astronaut falling feet first toward a black hole. As the astronaut approaches the event horizon, the gravitational pull on their feet becomes significantly stronger than the pull on their head. This difference in gravitational force stretches the astronaut's body like spaghetti. This stretching is not a gentle elongation. It's a violent and irreversible process that tears apart the very fabric of the astronaut's being. Atoms are ripped from atoms, molecules from molecules, until nothing remains but a stream of subatomic particles spiraling toward oblivion. While the astronaut scenario is hypothetical, the same principle applies to any object, including Earth, that gets too close to a black hole. The planet itself would be stretched and torn apart, its constituent matter spiraling into the black hole's singularity. Section 6. Ejection from Paradise Earth exiled into the void. While a direct collision with a black hole would be catastrophic, an alternative, and perhaps even more terrifying scenario exists. Instead of being consumed, Earth could be ejected from the solar system, flung into the cold, unforgiving expanse of interstellar space. As the black hole disrupts the gravitational balance of our solar system, Earth's orbit could be so severely perturbed that it's flung out of the sun's grasp. Like a stone from a slingshot, our planet would be hurled into the void, destined to wander the cosmos alone. This ejection from our solar system would be a cataclysmic event in its own right. Without the sun's warmth and light, Earth would rapidly cool, its surface transforming into a frozen wasteland. Oceans would freeze over, encasing the planet in a shell of ice. The atmosphere, no longer held in place by Earth's gravity, would slowly dissipate into space. The life-giving air we breathe would vanish, leaving behind a barren, airless rock, a chilling testament to the destructive power of a black hole encounter. Section 7. A world in chaos, atmospheric and oceanic upheaval. Even before Earth's hypothetical spaghettification or ejection, the approach of a black hole would wreak havoc on our planet's atmosphere and oceans. The immense gravitational forces would unleash a cascade of catastrophic events, reshaping Earth's surface and throwing its delicate balance into disarray. As the black hole draws nearer, its gravitational pull would begin to strip away Earth's atmosphere. The once protective blanket of gases that shields us from harmful radiation and regulates our climate would be peeled away, leaving Earth vulnerable to the harsh realities of space. The oceans, too, would bear the brunt of the black hole's wrath. Tidal forces would create monstrous waves dwarfing the largest tsunamis ever recorded. Coastal cities would be inundated, swallowed by walls of water miles high. Entire coastlines would be redrawn as the oceans surge inland, reshaping continents. The once familiar currents that govern Earth's climate would be thrown into disarray. Weather patterns would become extreme and unpredictable, with devastating consequences for life on Earth. Hurricanes of unimaginable fury would rage across the globe, while other regions would be plagued by relentless droughts. Section 8. The Earthquakes, Geological and Magnetic Disruptions. The approach of a black hole would not only wreak havoc on Earth's atmosphere and oceans, but also trigger cataclysmic geological and magnetic disruptions. The planet's very structure would be tested as never before, with catastrophic consequences for all life on Earth. The immense gravitational forces exerted by the black hole would generate tidal forces within Earth itself. These forces would pull and stretch the planet's crust and mantle, leading to earthquakes of unprecedented magnitude. Fault lines would rupture, unleashing seismic waves that would ripple across the globe, toppling cities and reshaping landscapes. Volcanoes, dormant for millennia, would roar back to life, spewing molten rock and ash into the atmosphere. Supervolcanoes, capable of eruptions that could blanket continents in ash, would awaken from their slumber, posing an existential threat to life on Earth. Earth's magnetic field, our shield against harmful radiation from the sun, would also be affected. The black hole's powerful magnetic field would interact with Earth's, weakening and distorting our protective barrier. This weakening would expose Earth's surface to lethal doses of radiation, jeopardizing all life on our planet. Section 9. A Glimmer of Hope. The Importance of Research. The scenario of a black hole approaching Earth, while terrifying, is highly improbable. The vast distances between objects in space make such an encounter extremely unlikely. However, the possibility, however remote, serves as a stark reminder of the immense power of these celestial objects and the importance of continued scientific research. By studying black holes, we gain a deeper understanding of the fundamental laws of physics and the nature of gravity. This knowledge not only expands our understanding of the universe, but also has practical applications here on Earth. For example, research into black holes has led to advancements in our understanding of GPS technology, which relies on precise measurements of time and gravity. Furthermore, the study of black holes pushes the boundaries of human ingenuity, inspiring new technologies and approaches to problem solving. While the prospect of a black hole encounter might fill us with awe and trepidation, it also serves as a powerful motivator. It reminds us of the importance of scientific exploration, the pursuit of knowledge, and the need to protect our pale blue dot, the only home we know, in the vastness of the cosmos.